Can everybody hear me? Yeah. Is that a yes? Yeah. Okay, how many in here are actually growing a small grain right now? Oh, thanks. Okay. So what I'm going to do, basically, over the next 40 or 35 minutes or so, is give an overview of what right now is happening in small grains production in Iowa. So a lot of folks in the room actually participated in a large experiment that we did, an observational study, and I'll explain what that is. So I'm going to broadly discuss a lot of issues related to small grains production, some biophysical things, so agronomic practices, soil fertility, and also some socioeconomic issues, socioeconomic. So how we think about small grains, what markets they're going into, things like that. Okay, so our project worked exclusively with organic growers in the state. Many of the practices and principles, I'd say 90+% of them, are applicable across the board, irrespective of your cropping system. So again, you know the State of the Union. We're here for the state of small grains in Iowa and oats, all right? Okay, so there's lots of things we could list about why we grow small grains, right? I could list them off one by one and give lots of reasons for those. Instead of doing that, I want to use your voices to explain that. So let's start here. First and foremost, it's the easiest and fastest way to get away from the corn and soybean alternation. It allows you to distribute your labor load a little bit if you're going to be harvesting in July. And then again, it allows you to plant your cover crops in July instead of having to wait until the late fall. Soil building, getting something else growing on that soil. Something more diverse growing on that soil. Something with deeper roots, something with shallow roots, something with tap roots, something with fibrous roots. Something that corn and soybean roots, something different than corn or soybean roots. That would not only help the soil health, but the soil livestock. Help regenerate our soil. Small grains benefit my operation by spreading my workload for planting and harvest, giving me income in the off-season, cutting my crop expenses, as small grains don't cost as much to grow, opening a wider window to allow better use of cover crops for soil building, and a better use of the land. 10 months with something growing rather than 5 months with corn. We love small grains for everything except the price and profit. They're great for soil health, soil aggregate stability. The small grains rooting system really improves over several cycles of the rotation, really helps improve the soil. It gives an opportunity to get a legume in there, to get more nitrogen fixation. It's all a plus. We like it a lot. It helps distribute labor. They're planted before corn and soybeans. They're harvested in midsummer so that fall is not a big ball up with harvest time. Plus, 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 plus. There's just that one big minus, and that's that profitability. And I know everyone's experienced that in here. So let's think about this for a second. On a yearly basis, this is how things break down. That's not highly scientific, but that's what things look like, right? We're making a lot of money on these two guys on a yearly basis, and less money on something like this on a per year basis. Okay, so that forces most growers into a system like this, right? But there are advantages to a system like this. So Dr. Liebman is here today, and he's going to talk about some of those advantages. And there's questions that we need to ask ourselves, right? Which system is more productive? Which system is more stable over time? All right? So I'm not going to go too much into this, and we're going to move back into some ideas around profitability. Okay, so what factors influence small grain production profitability? So things are obviously more complicated than this, but this gives a schematic of understanding what's going on and what influences this right here. All right, and there are varying degrees of control that we have over these things. So let's get things out of the way to begin with. All right, everyone in this room would love to control that. We have absolutely no control over that. Right? Markets. We have more control over markets. We can move things into different markets. But at the end of the day, if we're moving a commodity crop, most of us are looking towards Chicago, and that's informing how much we're getting for that crop. That leaves us with this. This is the realm of the controllable. We have a direct impact on how this works and how this shapes a crop in a given year. Right? We have control over this, and we can change management in order to benefit our system. Okay, so I want to talk a little bit about the research that we did over these last 2 years. So we did something that's called an observational study, and it does exactly like it sounds. We go and we observe things. We're not testing different treatments and seeing the results of those treatments. We go out And we measure things like soil fertility, plant stand, weed biomass, okay? At the end of the season, we had farmers give us their yield numbers, and we sent those numbers and those samples to grain millers, and they gave us some test weights back. So we get a bunch of biophysical information. We also send out a bunch of surveys. So we ask about their small grains growing practices, right? Tillage practices, history of growing things, right? And their perceptions around growing small grains. What's holding you back the most, all right? So a lot of the spots on this map are actually represented in this room today, which I think is pretty cool. And we just randomly split the site up, and we randomly picked farmers in each quadrant, all right? So as you can see, every dot in yellow is an oat grower, all right? There's 2 triticale growers up here. There's a few rye growers over here. We have some winter wheat going on. There's limited barley growing, and then spring wheat over here, all right? And that breaks down to look something like this, all right? This is organic small grains numbers, all right? But if I looked at the NASS data for the last 2 years, and oats represent more than that percentage-wise. Oats represent 74% actually, if we look at all acreage over Iowa over the last 2 years, all right? So if it's not abundantly clear why we study oats now, it should be. So we focused on oats because it's a low-hanging fruit, and a lot of growers are still working with oats in a cropping system. All right, so this is the small grain season, and this is just a developmental scale. In the same way we identify corn at developmental scales, we all know corn at V6, and we know soybeans at different scales. The same thing is true here with small grains, right? We've got emergence, and we move through seedling establishment, tillering, jointing, and stem elongation, and we get here to the end, ripe kernel, okay? So let's all visualize what that season looks like in our heads just for a moment, right? There are decisions that take place before, during, and at the tail end of this cycle. And let's think about what some of those questions are, right? So what's the preceding crop? How much I'm going to have to till under or work under? Am I going to have good soil to seed contact, right? Seed selection. Am I putting a lot of thought into the kind of variety that I want? Something with a good hull out percent, right? Or if I'm maybe raising livestock, something that could be a forage or a grain crop, all right? Drill calibration. Is everything set up to make sure that I'm getting the stand out there that I need? That the appropriate down pressure is on each seed tube, all right? Fertility. Is fertility up to snuff? Okay? And planting depth. Those may differ from small grain to small grain. And it obviously differs from our conventional crops. All right, mid-season. Right, am I growing wheat? Do I need a blast of nitrogen potentially for a good high-protein product? Right, weed management. Could be either chemical or mechanical intervention. Is that necessary? And fungicide application, which is obviously a big deal with the problems we have out here with oats. And then at the tail end of the season, when to cut? When is the right time to harvest, right? Do I swath or direct combine? What kind of fan speeds am I using? What kind of cylinder speeds? All right? So we're going to start looking at the preceding crop based on that study and fertility and how those match up with kind of baseline numbers that we've taken from literature and extension sources. Okay, so this is preceding crops in a rotation. And I was a little surprised by this large percentage of small grain following corn. And I think, honestly, in an organic system, it's a function of 2 things. It's a function of some guys wanting to rid their systems of soybean. Some people do not like growing soybeans, especially in organic systems. And it's also a function of high prices in organic systems. So folks are jamming more corn into a rotation. We saw a lot of corn, small grains, and then a legume. So I think that's a higher number. I think soybean is a safe bet, obviously, because you have little residue. And you've got a drier seed bed in that subsequent spring. And then 5% of the guys, which is not that many, are following a small grain with oats. All right, so this is just PAM 1688 and its ISU fertility guidelines and liming guidelines. And they do have a little system here, a guideline that's calibrated for oats. So this is calibrated for an 80 bushel per acre removal rate. And we've got some literature right here in Owen State that gives us some guidelines of where we should be. Okay? All right? So for phosphorus, somewhere between 16 and 20 parts per million. And for potassium, somewhere between 161 and 200, right? Even at these optimal levels, ISU is recommending these additions in pounds per acre, right? So this is a way of tweaking our cropping systems. Are we there at the right levels we need to be? Okay, and how does this compare with our growers? So you can see here, P was not really a huge issue. We have 20, but we still have 20% of the growers that are under that optimal P level. So they're under that 16 parts per million, right? We've got 40% here that are under the 161 parts per million K level. That's something to think about, right? Okay, let's start at the most important thing, or things, right? And that's quantity and quality. So the thing I want you to take away from this more than anything else, it's not just these numbers, it's the range of numbers, which I found to be quite a large range. So we can see over the 2-year study, we've got a range of 24 to 119 bushels per acre in oats. We also have a pretty serious spread on test weights. All right, but let's keep in mind these median values. The value's right in the middle, just under 90 bushels per acre, and around 34 pounds test weight. And Matt's got some numbers after 10 years that kind of reflect this as well. So maybe that's that ceiling right now in Iowa for stability. Okay, so this I want to explain. Each bar represents a different farmer's grain sample. Okay, so we've got test weight on this side, going all the way up to 45 pounds. That was the max there. And this line right here is really that lowest level that grain millers would like to accept for a milling quality oat. And that's 36 pounds per bushel. So you can see really where we're at right now. There's very few producers over these 27 that are theoretically able, without a discount, to sell a food-grade oat and receive that price. All right? So that's somewhat alarming. We can see even year to year how different things are. So if we look at the spread in 2014, we've got a huge range, and that's a little bit less in 2015. All right? And overall, again, this spread is pretty impressive, or maybe a little bit alarming. Okay, the test weight issue. This was a big deal for growers, and I know it's a big deal for growers. We asked growers, again, what kind of constraints do you have to profitability? And these are the kind of answers that we got. Market for low test weight, right? We don't have one. Oats need to be at least 36-pound test weight. If not, no one wants them. Very hard to sell light oats, light test weight. We heard this over and over and over from the growers. So the question we need to ask ourselves is, right, how do we make both producers and processors happy? And I don't totally know, right? But Bruce Roskins is here today from Grain Millers, and I'll have some more insight on that. Okay, seeding rate. This is the other thing. This is a function of a few things. We're going from 1.75 to 5 bushels per acre. Again, that's quite a spread. Part of this has to do with guys, a lot of guys are just putting out an oat crop for the hay crop, and I think they're seeding lighter. And some guys are thinking they've got to throw a lot of oats on late in the season if they're planting late, right? Oats are a little bit more fungible, they're more flexible, they're more plastic. If we plant them earlier, they tiller more, right? And we know if we're planting them later, we can go higher with the population, and they'll kind of selectively thin themselves out. Irrespective of those variabilities, I still think this kind of range of seeding rates indicates a lack of consensus around what we're supposed to be doing out there. So that was one thing I really wanted to study a lot about. So this next slide is really highly participatory. So I'm going to ask a few questions, and guys can actually scream out answers. All right? All right. Question number 1. How many plants per acre for corn? What's a common population? Don't be shy. No one here is shy. I know that for a fact. 34,000. Wade, always. All right. Next question. How about beans? What's the common population? What are guys growing at these days? 150. 140,000. This is like a cattle auction, I know, right? All right. Oats. What's a common population? Wade, you can't say anything here. What's a population we might be striving to? 2.5 bushel. All right. So what I'm trying to point out is that there's a lack of consensus around that, and maybe we should be looking at a population. So I've taken this population number from the Small Grains Field Guide in 2005. This population, what it looks like, it's about 28 plants per square foot, 28 to 29 plants per square foot. All right? This is not necessarily the ideal population. This is a population that I got out of the literature, and it's something to shoot for. Right? Other systems have had success at lower populations, and other systems might have success at higher populations. And that's something that I wanted to study. So I've got some more questions, and these don't have to be answered out loud, right? How many of us plant based on population with a small grain? Okay. How many of us change this population if planting late is delayed? Okay. Again, that's that Wiersma and Ransom publication. And Joel Ransom will be here today to speak with us, actually. Again, more stuff with population. So how do we go about determining that population in a very practical aspect? So this is a good guideline. It's kind of the back of the envelope calculation that you can do. And basically, the only thing you need to do for this is to have your seeds per pound count, all right? So what would this look like if we just walk through a calculation, right? If I'm looking for 1.2 million plants, setting an expected loss at 10%, and this is my seeds per pound in germination, the idea would be to plant 112 pounds per acre. I'm not saying to everyone, go out and plant 112 pounds per acre. I'm saying this is how you would go about calculating something like that. And seeds per pound numbers are going to change wildly year to year, which is why it's important to calibrate. All right? Okay, so it gets even easier than that. So this is a free tool that I found. It's out of Alberta, Canada. Their ag and forestry organization. So it's totally free. You just go to this website. The link's right there, and it's in your resources page. And this is what you're doing. So it's going to ask for a few things. I know it's hard to read. I'll walk people through it. So it's just a calibration tool, and you're going to put in oats milling, right? Desired plant population, plants per square foot. I put 28. Germination rate is 95%. Emergence mortality, I set at 10%. And we're going with 7-inch row spacing. This is the only really thing that you need to do. It says 1,000 kernel weight in grams. Okay? It means counting out 1,000 seeds and weighing that 1,000 seeds with a kitchen counter tabletop scale, right? So it's not a huge amount of effort, and it's worth doing. All right? And all you're doing is pressing this button, and you're getting these results. And I think that's pretty cool. And what does it say? Right? Seed 106.3 pounds per acre of oats. Okay? It tells you how many grams you need to come out per 100 feet. It also tells you per linear feet how many seeds you should be dropping, which in this case it says 19. So I think this is a pretty cool tool. It's totally free, and it's very usable. All right? Again, if you're interested in the bottom line, you can put the price of your seed in there. To seed 20 acres, right? It's over 2,000 pounds. It's going to cost you about $855 at a 40 cent per pound seed cost, right? Super great, useful tool. Okay, again, we wanted to test more of the differences between populations. So we set up 2 on-farm trials this year, okay? And what I want to point out is we were looking for trends and yield differences irrespective of management and geographic location, soil type, all of that. So forgetting all of that noise, because it's going to differ greatly from farm to farm, what are the differences between populations? All right? So we did 5 reps. This is what 1 block would look like, or 1 rep. We used the Sabre variety of oat. The harvested plot length was about 500 by 20. 2 sites this year, 1 in Hampton and 1 in Polk City. And we'll have 1 in Williams next year. How did farmers go about doing this? Pretty easy. In our protocol, we sent them this, right? And they calibrated their drills accordingly, right? These were some assumed values. So we expected stand loss of about 15%, set it higher in an organic system because of weed competition. They sent us a pound of seed, and I brought it to Seed Science and got this number for them. And this was another assumption. All right? So what are the results of this? Don't squint too hard, because you're not going to see any difference at all. All right? There's almost no numerical difference either, aside from statistical difference. But there are differences, and they're worth looking at. All right, so let's look just at the poundage difference in these seeding rates. We're going from 84 all the way to 138 with no yield difference. All right, what does this mean for your wallet? All right, we're talking about $30 here and almost $50 here. All right, again, in an organic system, it's worth considering the competitive ability of the crop, and it doesn't mean you should go all the way light on the seeding rate, right? You need to be aware of your seed bed and your weed seed bank and all that, right? But it does give us an idea of where we can lower input costs with a small grain crop even, all right? The next thing, varieties. All right, so these are the 2014 varieties we had. The most important reason, or I think one of the primary reasons we put a lot of effort into choosing a variety is because of this, right? Oat stem rust and oat crown rust. So we're seeing that right here. Okay, it's Puccinia. So we didn't measure rust. Wasn't that hard to do, but we didn't do it, I'm sorry. But we did see it on lots of different farmers' fields, all right? Obviously, like any other fungal pathogen, it's taking up leaf surface area and it's reducing that plant's ability to photosynthesize and assimilate carbon, all right? like any other fungal pathogen, or most fungal pathogen, it's mild to warm temps, especially warm temperatures at night, right? It's humidity. So dew is a big factor in the proliferation of rust. And it's also wind. So rust spores can be blown about 100 miles and infect the farm 100 miles away. So it's a pretty serious and it's a hardcore issue, right? This is called the Picinia pathway. So this is one of the ways we get rust up here. It's blown up from stuff that's overwintered in Texas and in other parts of the South, right? And the point is, there is an alternate host. So this rust does not survive without that alternate host. And that alternate host is the buckthorn plant, right? Which is a common hedge plant. It's an invasive species here, and it's all around. All right, so again, the alternate host, and then control. So our best control really is disease-resistant varieties. And if you're managing a system in this way, fungicide, right? It's worth considering the use of that. All right, and then we can see, how do our varieties stack up? And then when were they released? Okay, and then how do they do when it comes to rust? So we've got S is susceptible, MS is moderately susceptible, MR moderately resistant, and R resistant. All right, so for our experiment, we chose this. This is another experiment, Shelby 427. I know a lot of guys like growing Shelbys. All right, but this is what Shelby looks like over the course of last season. All right, it starts off looking like that. And then as the days go by, a week and a half later, this is what Shelby looks like, right? And that's localized, and rust is going to be localized and different in every location, but it's worth thinking about. So the questions I was really curious about, and we should all be asking ourselves are, right? Are we selecting the right varieties, and do we have the right varieties? All right, especially for this hot, humid climate and at this photo period. Okay, so we do have resources for this. Iowa, all right? The handout's not been given out yet, but we have handouts for everyone. And this is the yearly variety trial for 2015 for Nashua, right? So this will give you some indication of how an oat performs in Iowa, right? It's a great resource. And we still have them going on in the state. Illinois, right? We've got Dr. Fred Kolb speaking with us tomorrow. He's a breeder at Illinois, like I said, so he's breeding in similar conditions, similar soil types, right? Similar humidity, and that's going to be a really good resource for us. Other positives, right? So at Wisconsin, there's a new oat breeder. She's actually a grad of Iowa State. She's really interested in resistance and organic systems as well, and that's a positive thing and a resource that's close to us in the region. South Dakota has also employed a new breeder in the last couple of years. She's young and releasing new varieties, and the varieties Haiti, I think Hayden and Natty are recent, and they just came out, and they're in that variety trial as well. Seed processors and dealers. All right, we've got Albert Lee, Grain Millers, and Welter here this weekend. They know what they're talking about. This is their business, and they're very well knowledgeable about these varieties, and they're a good resource. Also, we can't discount this, friends and neighbors. So I said, look left and look right, right? There's a lot of knowledge in this room, and there's a lot of good information around what works and what doesn't in the cropping system. All right? The last thing I want to talk about of these factors was planting date. Right? So this is not going to make a lot of sense because we've got growers all the way up north in that map, it's all the way down south, and that's a function, those planting dates are a function of that location. But let's look at what planting date means, right? Why is planting date important? Okay? It should be pretty clear that this is date 1, this is date 2, and that's date 3, right? I think those photos are pretty indicative of why we want to plant early, right? There's a lush vegetative mat here. There's already tillering that's occurred, right? Yield, early yield potential is set at this point. In each tiller, there's a little seed head primordia, right? And let's look later in the system, in the season, what does this look like? Right, this is July 7th. This is date 1. It's almost ready to go, right? It's avoided that late season stress of heat, right? Date 3 is not even ready, not even close to being ready, all right? Things to consider. Why planting date is important. So this is just a tiny little picture that I took out in the field. And what it is, that's the anther, right, of that oat plant. It's the pollen sac, all right? So this is why planting date is important, right? Heat stress at this point, research points to, right, results in a greater potential yield loss than heat stress at any other physiological important stage, right? That means heat stress at tillering, jointing, or grain filling, right? What's happening here, right? We have a reduced number of seeds that are fertilized, right, and formed. This kind of late season stress associated with delayed planting dates means shorter periods of grain fill, right? And that means low quality. It means lower potential for a high test weight. Okay, so we're going to move out of some of the botanical stuff and plant physiology. Let's look at some more management factors, all right? There's a lot of things to consider here, right? Field cultivation. How do you get a good seed bed, right? Should I be culti-packing? How do I get good soil to seed contact, right? Harvest method, this is a big thing. The other thing that I'm really interested in, we haven't done any research, and it's pretty easy to do research, is understanding how much test weight can we pick up in processing. So I know not everyone's got seed cleaners and clippers, but those of us that do, let's think about how we can help this community by doing trials. What does it cost to pick up a couple pounds per bushel, right? To run that and your labor. So I think those are things that we need to start thinking about and moving forward with. Let's look a little bit more closely, right? Again, there are lots of practices, preference, and ideas around what works for small grains. No one operation is the same. Equipment's going to vary. You'll know what works, but let's work together to see what we can do. All right, let's look a little bit more closely at these, right? Combining versus swathing. So this is what the breakdown looks like of the growers we have, right? About half of the growers that we researched, that we worked with, are direct combining, and about 38% are swathing. 10%. Can anyone guess what 10% is? Okay, so this is not very common in Iowa, but these are shocks in Fairbank, Iowa, from an Amish community. So I thought that was kind of interesting. I just wanted to share it. All right, harvest method and timing. Let's think about a little bit this more. All right, so we've got wheat and barley and oats, right? So the structures of these determine how they thresh out, right, and how they dry down. It's important to know that these differences have those repercussions. All right, so let's look a little bit, let's get familiar with the botany a little bit. So if you're talking about triticale, rye, wheat, or barley, you're talking about a spike. That's what the seed head is called, right? And if we're talking about oats, we're talking about a panicle. It's unique in that, okay? This is the peduncle. It's the stem under that seed head, right? And what we know is the chaff are called glooms. This is going to play into what I'm going to talk about. All right. So you're not picking up any dry weight after physiological maturity, right? When that plant starts to senesce, it starts to brown down, you're not picking up any more weight. What are those kind of visual clues? When is physiological maturity? What does it look like, right? That peduncle, this area right here, becomes tan or brown, right? The plant is not bringing up water or nutrients into that seed head, right? It's theoretically dying or it's starting to die, all right? Panicle, tan or brown. 75% of this gloom surface, tan or brown, okay? When we're talking about physiological maturity, we could be talking about grain at 35% moisture, sometimes greater than that, all right? And that stem is still going to be very, very, very green. Okay. Swathing can begin at this stage and go down all the way to about 20%, right? The plant's not living anymore. It's not putting on any more weight. You can cut at this point, all right? Direct combining, you want to be under 20% moisture, right? If you're direct combining, you want to avoid shattering losses, and obviously you're not going to want to put a lot of green material through your combine guts, right? It doesn't work very well, all right? So I want to move away from the agronomy stuff and then talk a little bit about farmer knowledge and perception, all right? So this is what we looked at before, right? But reimagine a little. So, right, climate's really affecting our decisions, and economic opportunity is affecting our decisions, and climate affects economic opportunity, right? This is why we grow corn up here, and they grow rice down in Arkansas, right? This really shapes this. But what I think really is going on is it's going through a filter, and that filter are our perceptions, right? It goes through us, and we intuit those, and we think about how we're going to manage an operation, right? And then it goes to this, all right? So we wanted to know more about farmer perception. So we asked farmers, okay? We used surveys. We asked them about production and profitability constraints. We had a list of 20. Right? There's early season rain and mid-season rain and late season rain, all sorts of different things. So the top 3 that were selected, right? Too much rain, mid-season rain, delayed planting date, and annual weed pressure, right, for organic growers. And let's look a little bit closer at these, all right? Do you remember that control and limited control? So mid-season rain, we have no control over that. Delayed planting date, we have some control over that, right? We can pick our previous crop, right? We can pick a crop with less residue. We can till in the fall, potentially, if we want a nice clean seed bed, right? And annual weed pressure. We have greater control over that, right? So these are things that we have a little bit more control over. More question for us to think about as a community, all right? How much thought and energy do we put into small grains production? Right? Do we treat our small grains like we treat our corn and soybeans? Do we make an effort to control factors that we can? All right? If the answer to these questions is not much and no, how did we arrive at this mentality? So we're going to go back and we're going to look a little bit at history now. Okay, harvested small grain acreage in Iowa over time. All right? So this is barley. It's starting here in 1866, and NASS stops recording information in 1970. All right? And these are harvested acres in the hundreds of thousands over time. This negative trend, despite that kind of weird anomaly. All right? Harvested rye acreage. This is ending in the early 80s. NASS stops recording data then, right? And harvested wheat acreage, right? That negative trend is really visible here. But we're still growing wheat in this state, okay? Again, I took this off of NASS, the National Ag Statistics Service. All right, let's look at oats now, okay? So I think this is a pretty interesting and somewhat sad graph. Let's look more closely, all right? In 1950, there are 6.5 million acres planted to Iowa in oats. Right? In 2015, we've got 57,000. Okay? Acreage has been reduced from 20% of the landscape to 0.2% of the Iowa landscape. That's a 100-fold reduction over 66 years. All right? So I was really curious, what happens when you lose this, right? Obviously, ecologically, we know what's happening. There's when water works. What happens when you limit cropping systems, when you move to monocultures? We're aware of those changes. But other things happen too, and we lose other things, right? Loss of associated infrastructure, right? We lose things like local mills. We lose seed cleaners, right? And seed milling equipment on small farms, right? There's a few equipment out there. They're kind of dispersed. They're decentralized. There's not one in every county, all right? And getting these becomes a bigger pain in the butt, right? I've talked to, anecdotally, lots of farmers who spend a lot of time on Craigslist looking for swathers, driving to South Dakota for swathers, driving way out of their counties for swathers. Aside from all of this, equipment and infrastructure, right, the most important infrastructure that's lost over time is the knowledge infrastructure. Is how to clean, what screens we're using to sieve out grain, and how that works. So we lose that over time, all right? So instead of ending on a negative note, I want to end on a positive note. All right, so who was at the cooperators meeting? Just raise your hand. If you were at the cooperators meeting. All right, so Tom Franzen talked about this flywheel, all right, which I thought was really cool. It's like a positive feedback loop. When you start pushing it, right, other things, good things start to happen. But you have to overcome that initial inertia. So we're kind of at that point now, but I think it's a good moment for small grains. And let's think about our different parts and where we can do with small grains. So farmers and research, right? I've got another 8 OnFarm Trials this year. We're getting more and more information in Iowa about how small grains are grown, right? PFI has done a really good job at getting multiple sites for variety trials, and they're going to have a lot of oat research going on over the next year or so, right? We've got cropping system research, which is really showing really clearly that when you start to add more crops to a sequence, things look pretty good, economically as well, all right? The other thing that we really need are these, all right? So the trends I showed you in Iowa, they're not just regional, they're global. So we're losing small grains acreage in the whole world. But demand for these products, especially a product like oats, which is heart healthy, there's the high beta glucans, that demand is growing. So theoretically, we're in a favorable environment to be an oat producing state. Something to think about, right? And Bruce is going to talk a little bit more about that. So I think we can get here, but it's going to take all of us kind of overcoming the inertia of that flywheel and pushing together. So that's all I have today. We'll open it up to questions.
Okay, thanks, David. I'm going to run with the mic, so if anybody has a question for David, I will come to you, and please announce it to the group.
Hi. Yeah, I got a couple questions on that yield test relating to population. Was there any difference in the test weights?
I haven't crunched the numbers on test weight yet. So as soon as I get them out, I'll get them to PFI and we'll get them out to you.
Okay, and then on, you mentioned on something there about a possibility of using fungicide, and I was wondering if has anybody tried to use copper or sulfur, something or other, so that it would be okay for organic?
So I still think input-wise and paying for that input in an organic system, the best bet is finding a really good resistant variety. If you're not in an organic system, your best bet is probably something like Headline or Stratego and a seed treatment. So honestly, I think if you can't hit that test weight every year, it's not really worth investing in that fungicide. And there's not a lot of organic research right now that's looked at the effects of something like copper. I think it would probably be pretty cost prohibitive to spray a field of copper. Yeah. Anyone else? Okay.
Do you know of any data that compares oats for grain with oats for grazing in terms of income?
Ooh, I have not looked at the data that's comparing grain yields and forage yields for oats, so I can't speak to that, I'm sorry. Yeah.
Yeah, so if I was going to add one thing, it might fall under industry support, but it would be keeping in mind financing. So talking to conventional farmers, I will talk to them and they say, well, I'd like to grow oats, but my banker won't let me. And so that needs to be part of this flywheel, if you will, is the long-term sustainability of the system in terms of an economic payoff rather than just farming year by year.
I think when Matt speaks, you'll really see that economically, there's a very compelling case to a 3- and 4-year rotation. Right? And those are hard numbers over 10 years. It's at one site, but those are hard numbers that show the bold economics of what happens when you go to a 3- or 4-year rotation. So the information is out there. I think it's about, as a farmer, bringing that data to your banker and being equipped, right, and prepared so that they know you're taking that investment seriously. Yeah.
Is there a percentage number from a tiller grain produced versus the plant itself produced? Like, is a tiller going to produce? Is the tiller going to produce like 25% less grain than the actual root of the plant?
So the plant sends up multiple tillers, right? And for the most part, in the varieties we're using, one tiller puts up one panicle, and that's about it. And that one panicle is harvested. I'm not totally sure if that was the question.
Well, sort of. When we drill, we have 7.5-inch spacing. And I've tried to do some different tests where drilling versus broadcast and rolled in, and haven't really come up with a good test yet. But I'm wondering if it would be beneficial to double drill. With RTK now, you can skip over, and if you overlapped, and it wouldn't hurt. But if you could just get a planted seed on a more square inch basis, would that help with yield?
Some of that is true, and some of that is not true. So for the most part, the easiest way of getting grain onto the ground and getting the best spatial distribution so that crop can harvest light and intercept it properly and grow and have a decent seed head is by using rows. Right? There's research in Denmark that looks at when you start to move plants in a more, I guess, square arrangement. So the more you can do to increase the surface area around that plant, so that's uniform around every plant, the better that stand will be. But that's really hard to do with equipment. So when you drill crosswise, you don't totally get that, right? You get this jamming. So you get more than one plant every square inch. You get these jams linearly, where you've got lots of seeds here, then you've got these gaps. So right now, yeah.
I didn't specifically mean cross-drilling. Drilling in the same direction, but just nudging your planter or your drill over. And then with machinery drift, you'd have a few places where you'd have the same seed right on top of the previous furrow. But I did some experimenting with the drill empty, and I was watching, and it's pretty much dead on. There's 3.5-inch spacing there.
There are pros and cons to moving to a tighter spacing, right? And again, I don't think I could speak to this because I haven't done the research behind it. So there's some research in other countries where they look at tighter spacing, right, where you have a more competitive stand. There's also research in other places in the US that's looking at larger spacing and cultivation. So again, I don't totally know what works best in that respect. What we're dealing with right now is lots of guys with 6- and 7-inch drills that want to just easily go out and plant and not think about it anymore, and how to best manage with that equipment. Yeah.
Any of these trials have no-till on no-till ground?
I've not done any no-chill trials, no. Yeah.
And how about crop insurance?
Oh, I'm sorry I can't answer that one. Yeah.
There's been a lot of work done in Europe on narrow row spacing and more equidistant spacing. So the long and short of it is, as plant population goes up and as row distances get narrower, weed control improves dramatically. So you always have a problem with lodging as the population goes up because the stems get thinner and thinner. So there's a balance there, but you can see some pretty dramatic increases in weed suppression by narrowing from an 8-inch or a 7.5-inch row down to 3.5 or 4, even within the same population. And then as your populations go up, you can also see a higher competitive ability of the crop against the weeds. That said, if you want to have a good underseeding of clover or alfalfa, that might not be what you want to do. So backing off on the seeding rate and going to a little bit wider might be more beneficial from the standpoint of establishing clover. And then coming back 3, 4, 5 weeks after the crop has been harvested and then clip the stubble to keep those weeds down rather than try to suppress them directly with the high population.
This question is for you, Matt, just to follow up to that. How are they accomplishing that planting? Have they got a double drill gang of a drill, or are they planting back, or do you know how they're doing that?
How are they getting it done? They have much narrower rows because they use... The drills I've seen have been offset, so rather than just a single set of double disc openers in one line, they're set front and back a little bit so you can stagger them and move to a higher population density and narrower row spacing. Yeah. How much more yield? Depends on how strong the weed pressure is. So in nearly weed-free conditions, you'll get the same results that David showed, which is across a pretty wide range of populations the plants compensate and you don't see a big difference in yield. Unless you're planting late, in which case higher populations make up for a lack of tillering. If you're in weedy conditions, the advantages of narrower row spacing and higher population densities can be pretty dramatic. And the major weeds I think you're going to see interfering with small grains that are spring planted here are things like common lamb's quarters and giant ragweed.
In the trials that you have done the last 2 years, how often were those oats combined with an underseeded forage crop? Were they not at all, or was there a mixture?
So at Margaret's, they used red clover, and at Aaron's, so at the site in Hampton, there was a red clover underseeding, right? And at the site in Polk City, it was also a red clover underseeding.
So any data on how that affects yield
Again,
one way or another?
We literally just finished counting and weighing all that data, and as soon as it's out, I'll get it to PFI.
Okay.
Yeah.
Well, mine is a little bit related, I think, to what he's asking. Since Matt mentioned that seeding clover, I'm wondering about what the experience is as to when that clover is seeded, with the oats or into it as a later date. Sometimes if it's a wet year, in my situation, you'll get pretty big clover in there, and when they smell at it, the grain inspection, they'll say there's weeds in it.
We seed in the same pass that we plant the oats. So we use a grass clover box on the drill. I've seen situations where clover gets competitive with grain. If you delay harvest for too long because it's too wet when you want to combine it, the clover grows up and that can be a problem. Most years it's not, in my experience. Some people will, organic producers in Europe and in the northeast US will use a springtime harrow, like a lely, and go over the cereal crop at about the 3 or 4 leaf stage, and when they're doing that, they'll broadcast clover and stir it into the ground using that set of springtimes. That can be good for weed control and delaying the planting of the clover so you don't get that kind of competition. If you're working with winter cereals like wheat, frost seeding is common. So you're out there when the ground is freezing and thawing and you just sprinkle the seed on and the frost action of the ground works that seed in and you get a good catch. And we've done that a lot in winter cereal production. And I've never seen red clover become too competitive with winter wheat. But the winter wheat has a huge head start. So,
of those 41 growers, no one was applying clover in a spring cereal at a later date. So everyone had a seed box and was filling it up with a clover or a pasture grass and drilling it all at the same time. Like Matt said, the only time when we had different dates of seeding for a clover or an underseeding was a frost seeding during the winter. That was true across the board. Another thing, of the trials we're doing, we'll have a few farmers looking at the effects of some early season weeding. So like Matt was talking about with a harrow, coming in early season when that plant's in a 3 or 4 leaf stage and the crown roots are set in the ground, right? We'll be looking at that, the effects of doing that, but with a rotary hoe, as it's a common implement that everyone seems to have here. Luke.
I was really interested in those graphs you had that showed all the yield or all the acres in production. Surely we were doing research back then. And what of that stuff did you find in your work that was really pertinent to today even?
Yeah, so at a certain point, I mean, not that long ago, Iowa was actually really well known for oat breeding. There's a professor named Ken Fry, who actually passed away in the early 2000s, released a ton of varieties, was really well funded by Quaker Oats, and is really responsible for all the information that we have now in Iowa when it comes to plant physiology, right? Responses to tillering, fertility responses. He did all of that research over a very long career at Iowa State. So we have access to that as graduate students and researchers. So obviously that's incorporated into my scientific questions, right? And how I look at things and what I know about grain. Again, right now, currently, we have more of a cropping systems approach and how small grains fit in and help that cropping system. But we don't actively have a breeder right now in Iowa working on some of these issues.
Do you have any data on that adds the value of what the oat straw would be worth in a? You have the data for the grains, but how much does the oat straw and the baling cost and things like that?
So Matt has some really good budgets that talk about the total returns on a 3-year system. And included in those returns are things like straw. And he can make a compelling argument, especially when soybean prices are low, that oats are quite favorable actually, and they look pretty good. I don't know, Matt, do you want to talk about that now or in your, well, wait on, yeah.
We usually take off a ton of straw, and prices vary depending on where you can sell it, but we usually budget it at $90 to $100 a ton. If you have a bunch of strawberry growers who want clean oat straw, you may do better than that.
Yeah.
Right. Well, I can't speak to the differences in specific varieties, but there's enough difference in oat heights that you could get a bit more straw. The short varieties are less likely to lodge, but you'll get less straw. The tall varieties may be more likely to lodge, but you'll get more straw. Yeah. So there's a balance there, and I can't say what's best. And depending on growing conditions, the height of the straw will be more or less. But we, over a 12, 13-year period, we've averaged about a ton of straw per acre, and the ag economist I work with typically puts a price on it about $90 to $100 a ton.
Matt, could you mention what variety you're using?
It's an Indiana variety, IN, what,
INO
01, I can't think of the
9601.
number. I'll put it up a little bit later.
Yeah.
I buy it in Iowa.
So then another thing, so the plant heights are always listed in a variety trial, and it will give you some baseline information as to how large that plant's going to get, which is correlated obviously with the straw yield. So in your system, you've got animals. Your ability to chop mid-season gives you some more options if you're seeing lodging. That's something to think about. Maybe it's worth going to a taller variety. Right? Any other questions?
Oh, all right.
David, could you speak to the variability in fertility systems? Was there a commonness in a lot of those tests, or has there been some work specifically on what fertility solution was applied ahead of some of those tests?
So if there's been research as to the effects of fertility, or?
What different programs are you using?
So in organic systems? Yeah. So for the most part, I don't think anyone's adding supplemental fertility in that small grain year. We didn't have anyone, we had very few growers, maybe 2 out of the 41 that were adding manure before that small grain, right? And so in an observational study, we're not supposed to make causal links, right? Statistically, you can't do that. It's not how it works. What I will say though, and this is a very, very small, I shouldn't even say this. So we had one producer that had very high yields, and he's well known as a good oat producer. And he did add turkey litter before, and he did have good yields. I mean, if we do look at the basic information, right, that 20% of the growers are below optimal phosphorus levels, right, and 40% are below optimal K, it does stand to bear that, yes, there's room for improvement there, and we could start tweaking that. And I think especially if you're close to a lighter source of manure, like a turkey litter or a poultry litter, that's an easier addition than obviously throwing on a bunch of manure. And that's worth thinking about. Yeah.
Did any of the growers just leave out the underseeding?
Yes. So we had a few growers that didn't use an underseeding at all. Some guys came in mid-season with a cover crop, and it was easier for them to manage. Some guys aren't selling hay, they don't have animals, and they have no interest in that underseeding.
So when they're being more selective to just grow oats then, do they have an advantage then because the underseeding isn't competing for moisture in a dry
So
year?
it depends on the underseeding. Again, Matt's got some data that shows that statistically yields in oats are always lower in a clover year, right? Clover is more competitive than something like alfalfa, and the yields above alfalfa are going to be greater. So it's worth thinking about that. Some guys want to accomplish everything in one pass, which is really the most of the reason of why you're putting that legume in there at that time, right? I don't know, it depends also. Guys way up in the northwest are not getting that precip midsummer. So they don't really want to bet on coming in midsummer, terminating that oat, harvesting it, and then planting a cover crop. For them, that's too much of a gamble. If you're in southeast Iowa, maybe that's something to think about a little bit more. It's going to really be site dependent.
Okay, I think we have time for one final question. Or David has something to say.
So if there's not a question, what I want to do, because I'm a grad student, I want to give everyone here a quiz. So this is something that I pulled from University of Minnesota's risk management. It's an organic risk management guideline. All it does is asking you a bunch of questions about small grain production, about where a small grain fits in a rotation, right? About disease pressures, about planting dates, things like that. It's baseline information, right? And you're going to get a score at the end. It's not for anyone to see except for you. But it gives you a sense of how ready you might be, or how much at risk you might be for producing a small grain crop. And I think it's a really good tool for understanding where we are right now. So is everyone cool with taking this? Yeah? Cool. You want to help me hand them out?
Yeah, sure.
All right. Yeah. Yeah. Thank you. So obviously, I didn't do any of this alone. I drove, there's 41 sites across Iowa. I think we drove more than 20,000 miles in Iowa over 2 years, which is a lot of driving in Iowa. I hate Highway 20. More than anyone else, I really have to thank all the farmers. I really bugged you guys a lot over these 2 years. And I think I've probably learned a lot more from you guys than you have from me. I'm hoping to repay that in the coming years. And I think we'll be able to do that with some of the publications and extension stuff we're trying to pump out. Obviously, Mary and Margaret, thank you a lot. And to my fellow grad student, Rafael, who's not here right now, and all the undergrads that helped us with all the sorting and all the really boring stuff. So thanks a bunch, and thank you all for listening to me.
Okay, thanks a lot, David.